Okay, good afternoon, my dear students. Welcome to another session of engineering programming. We are going to do functions 2 today, functions part 2. We got 10 students and hopefully more will join us as we continue today's session. I'm going to switch off my camera and open the lecture slides so you can concentrate on the lecture slides. It's 1 minute past 2. We start now. Okay, welcome to another session of engineering programming. This is our second last topic. Next week will be the last topic of this semester. Today we'll be learning about functions and multiple files. Okay, this is what we're going to study today. We'll examine the structure of a more complex programs which have got multiple functions, explore the use of more complex user-created functions, and explore the use of more than one file for a program. So these are some of the things you're going to look at today. And perhaps some of these concepts you will be implementing in your assignment. Now, in the beginning, look at this program that I have here. I have main function. I have got another function called function 1. I've got another function called function 2. Now, the question I want to ask you is, what is wrong with this code? Anyone can reply and tell me what is wrong with this code? Anyone?
There's no prototyping.
Yes, very good. We have not declared these functions up here. Okay? Remember I told you last week, if you don't want to declare functions, in other words, if you don't want to prototype functions, just put your calling function, in this case, which is main, right down under. Okay? In that case, you don't need to prototype. But in this situation, the compiler will generate an error. So how do we fix this problem? Very simple. We prototype or declare the function. Then the compiler knows that, hey, in this program, he's going to use two functions. Okay, function 1 and function 2. Moving on. Discussed from last week that a function has got a name, a function has got a return type, okay, and a function has got arguments or parameters. Okay, if a function does not return a variable, then we write over here void. If it returns, then we put the data type of the variable that it returns. For example, if it's returning integer, we write over here int. Another test for all of you, look at this program and tell me what will be the output of this program. Anyone? Do a mental tracing and tell me what
4.
Yes, very good. You're right. 4. How do you know? The compiler goes to the main function, and right in the main function, you're giving a value to num variable. What is the value? The value will be calculated in the try function. So from here, it jumps to the try function. It returns the value 4. Since 4 is integer, the return type should be integer. So 4 will be returned and will be the value of num. And then using printf, you say, hey, show me the value of num, which is 4. So it will show you the value 4. Very good. Now, again, going back to what we studied last week, we studied that variables are passed by value and by reference. Okay, so what does it mean if you pass by value? For example, if you call a function swap1 and you pass the value of x and y to this x and y, only the value will be passed. There's no relationship between this x and y, which probably belongs to another function, and this x and y, which belongs to swap1 function. This is called by value. We also studied last week that we also have something else known as call by reference. In call by reference, you use the reference symbol, also known as address of symbol. So when you do call by reference, you are linking, you are saying address of x is linked to the value of x. Address of y is linked to the value of y. Okay? Remember, the indirection operator over here means value of. This means address of. So the address of this variable is going to be linked to the value of x. When that happens, these two variables are connected to each other. So if you change the value of this x, guess what? This value also changes. So this is what we studied last week, pass by value and pass by reference. It's important for today's lesson because we are going to study when you use arrays or when you use structures, is it pass by value or pass by reference? Okay. Now, whenever you use arrays, by default, remember that it is pass by reference. Okay. All arrays pass by reference by default. Okay. When you declare an array in a parameter, you have to say the type of elements, that is the data type, location of the first element in the memory, the reference, and the size of the array. Okay. For example, if you're creating a one-dimensional array, you declare it like this. Now, if you want to put an array inside your function, then your function declaration can be like this. The first one, you see, you just leave the square bracket empty, or can be like the second one where you mention the dimension or the size, or can be the third one where you just use the indirection operator. That's it. Either like this, or like this, or like this. So when you put an array inside the argument, when you do function prototyping or function declaration, and one of your argument is an array, it can be declared in this way, or in this way, or in this way. Now let's look at an example. Look, here I've created, first let's look at the structure of this program. I've got a main function, and I've got a print vector function. Two functions, 1, 2. Now, since this is a user-defined function, and my main function comes before it, I have to do function declaration, also known as function prototyping, which I do. Either I can prototype my function in this way, since I'm using array. Array argument can be declared like this. The second way is like this. The third way is like this. All the three ways will be acceptable. Now let's look at the program. Yes, let's look at this program. Now, what I want you to do is follow me doing a tracing. Remember, I told you many times that the only way you can learn programming is by doing tracing. Tracing is very important, sort of a dry run, so that you become really good at this skill. And at one point, you can do tracing mentally when you look at code. Okay. So how many functions I have in this program? I have got two. I've got the main function and I've got the swap vector function. Two functions. Now, since the calling function comes before the call function, I have to do function prototyping. There is my swap vector function consisting of how many arguments? 1, 2. The first argument is a float data type. The second argument is integer data type. Now, the first argument, float, is a array. Look over here. It's a array. Now, the compiler always goes to the main function. Now, what happens in the main function? The main function opens here, ends here. In the main function, I declare an array consisting of 3 subscripts. This dimension is 3, consisting of these 3 values. That's it. So, vect1 array is declared with 3 values. So, this is what it will create. Vect_1 consisting of 3 subscripts. An array subscript always starts from 0. Okay, and the first value is 3.5, 6.2, 7.1. Okay, an array subscript starts from 0 since the dimension is 3. First subscript is 0. Second address is 1. Third address is 2. Okay, now what happens is, remember we are doing a tracing. When we do tracing, we go line by line at the code. We mention the variables where they belong, and we draw a computer screen and see what will be the output. That's what I'm doing over here. Next, printf. Original vector, since they are float data type, %f, 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 show me vect10, which is showing 3.5, then it will show 6.2, then it will show 7.1. So this is what you will get on the screen, correct? Original vector 3.5, 6.2, 7.0. Okay. Now, next line, what happens is we call the function swap vector. We are calling the function swap vector. So from here, it jumps and goes to swap vector. But it doesn't go empty-handed. It's going to pass vect1. Vect1 values 3.5, 6.2, 7.1 is going to be passed right from here to v1. So we have another array declared in the swap vector function. And these 3 values are going to be passed to v1. Okay? So when you call this, it passes the value of vect1 to v1. So immediately your v1 will have these values as well. But remember one thing, my dear students. When you pass an array from one function to another function, it is going to be called by reference. That means all the subscripts of vect1 and v1 will be connected to each other. In other words, if you change this, this also changes. If you change this, this also changes. If you change this, this also changes. This is called by reference. What about the second argument? 3 is passed to length variable. Is this also called by reference? No, this is called by value. If the length value is changed inside this function, it won't change the 3 value over here. Okay, this is called by value. Since you are passing an array is called by reference. Now let's go ahead and do a continuous tracing and see what happens in this program. So vect1 value is passed to v1. So whatever value you have in vect1, you have the same value in v1. Since it's an array, all the subscripts will be connected to each other. Okay, remember it is called by reference. Now that you are in here, let's see what happens in swap vector function. Now, 3 is passed to the length variable, so the value of length will be 3. Next, I'm creating another variable known as I. Okay, I'm not giving it a value yet. I'm giving it a value inside my for loop. Next, I create another array known as temp. Size is 3. Another array is created known as temp. Size is 3. And the values inside them will be 0, 0, and 0. So there it is. Temp consisting of 3 subscripts. And the value is 0, 0, and 0. Now we go to the for loop. Okay. The first for loop. I is equal to 0. Remember the I value was nothing. Now it is initialized to 0. Remember our for loop. First initialization, then condition. If the condition is true, goes inside the loop. After that, reinitialization, then condition. This will only happen for the first time. Then it will just be an activity between the condition and reinitialization. So this will continue as long as this is true. The moment, my dear students, the moment this is false, it will get out of the loop. Okay, so there we go. Initialize I is equal to 0. 0 is less than length. 0 is less than 3. True goes inside. Temp, length minus 1. Length value is 3. 3 minus 1 is 2. Why do you have to decrease it by 1? Because there is no 3 subscript. The maximum subscript address number is 2. That's why you have to decrease it by 1. So once again, temp, length minus 1. So we are talking about temp. Length is 3. 3 minus 1 is 2. 2 minus I value is 0. 2 minus 0 is 2. Temp, 2. Temp, 2, we are talking about this subscript. This is temp array, 2 subscript. We are talking about this location. Is equal to V1 I. I value is 0. V1, 0 is 3.5. So the value of this will be 3.5. Okay. Next, we do a increment. I plus plus. 0 plus 1 will be 1. Then from here, it goes again to the condition. 1 is less than, length value is 3. 1 is less than 3. True goes inside. Temp, length minus 1. 3 minus 1 is 2. 2 minus I is 1. 2 minus 1 is 1. Temp, 1 subscript. So we are talking about this. Temp, 1 subscript. We are talking about this location is equal to V1 I value is 1. V1, 1 is 6.2. So the value of this will be 6.2. Then again, it goes to the reinitialization of the loop I plus plus. 1 plus 1 becomes 2. Goes to the condition. 2 is less than, length value is 3. Condition is true. Goes inside the loop again. Temp, length value is 3. 3 minus 1 is 2. 2 minus I value is 2. 2 minus 2 is 0. Temp, 0 subscript. So temp, 0 subscript. So we are talking about this location. Temp, 0 subscript is equal to V1 I. I value is 2. Okay. V1, 2 is 7.1. So 7.1 value will be stored here. Okay. Sorry, 7.1 value, yeah, will be stored here. Now, once this is done, then it goes back again to I plus plus. 2 plus 1 becomes 3. Again, it goes to the condition. The condition says I should be less than length. Length value is 3. I value is 3. 3 is less than 3. True or false? False. Since it's false, it gets out of this loop and goes to the next line of code, which is another for loop. So it comes over here, and here we say I is equal to 0. I value is changed from 3 back to 0. Okay? Again, I is less than length. Length value is 3. So 0 is less than 3. True goes inside V1 I. That is, I value is 0. V1, 0. We're talking about this subscript is equal to temp I. So this value will be changed to temp 0 subscript. So 3.5 will be changed to 7.1. Okay. The moment you change this to 7.1, since V1 is an array linked to vect1, guess what happens to vect1 0 subscript? This also changes to 7.1. Remember, it's called by array. So every time you increment this, when I becomes 1, then you're talking about this. So this value will be passed to this, and then this will be passed to this. Okay? Although it's the same value, but again, the value from here will be passed over here. It will overwrite with the same value. Again, it will overwrite. Then the next value, once it becomes 2 subscript 3.5 will be passed to 7.1. So this becomes 3.5. And when you are changing the value of V1 array, since it's an array, it is linked to vect1. Vect1 2 subscript will also change to 3.5. After you have finished with this function, you come back to the calling function. You come to the next line of code, okay? And then it will show you swapped vector value, okay? It will swap the value for you, okay? Now, I went through this code by doing a line-by-line tracing. No matter how complicated code it is, if you do tracing, you can get to the bottom of it and understand it better, my dear students. So if you haven't done tracing in your studies, please do so. It will enable you to learn programming better. Now, in two-dimensional arrays, what you need to do is you have to mention the data type, the location of the first element, okay? And you need to say the size of all dimensions except the first one. For example, in two-dimensional, you don't need to mention the first one. You see, you can declare it in this way, or you can declare it in this way. If it's three-dimensional, you can declare it in this way, or you can declare it in this way. You don't need to mention the first one. Okay? Remember, two-dimensional, three-dimensional matrices, arrays. The first one is the size of the rows. The second one is the size of the columns. Now, look at this example, matrix passing to a function, okay? Look at the program, the skeleton of the program. I've got a main function, and I've got a print matrix function. Two functions right over here, okay? I'm doing a function declaration over here, okay? Now, you see, when I do a function declaration, since it's a two-dimensional array, since I'm having a 2x2 matrix, 3x3 matrix. So what I'm going to do over here, the first one I can leave it empty, okay? Now, what I do is I go to the main method as a compiler. I always go to the main method. I create my first matrix, a 3x3 matrix, and I populate it. So the matrix has been created with the actual values. There, the first one is rows, 3 rows, and 3 columns. And the values inside will be does. Okay? Next line, I'm calling my print matrix function. It goes to the print matrix function, and it passes the value of this array. It passes the value of this array to M1 matrix. You see, you call the function, but you also pass the value of this 3x3 to another 3x3 matrix. You have to make sure that this is also 3x3. Okay, so another matrix will be created. Okay, in other words, another two-dimensional array will be created, known as M1, and all the values of this matrix will pass to M1. So guess what? You will have the same values. There's only one subtle difference. Since it's an array, a two-dimensional array, the values of 0, 0 subscript will be connected to the value of M1, 0, 0 subscript. The value of matrix 1, 2, which is 2.2, will be connected to the values of M1, 1, 2 subscript. Okay, so if you change this value, this also changes, and so on. When you pass 3 to width variable and another tree to the height variable. This one is called by value. But since matrix is an array and M1 is also an array, it's going to be called by reference. Then what happens inside this function? You say printf, show me the matrix, and then use a for loop to display the matrix values. Now, how does it work? Remember I told you the first for loop is for the rows. The second for loop is for the columns. So it starts with j is equal to 0. Why? Because we're talking about this row. Then I is equal to 0. So we are talking about this cell. Then it will 0 will become 1. We're talking about this cell. Then we're talking about this cell. Then it goes back again to the main loop. 0 will become 1. So we are talking about this row. Again, this cell, this cell, this cell. Then we'll go to the third row. Then we start with a 0 column, 1 column, and 2 column, and so on. So remember, the first for loop is always for the rows, and the second for loop is for the columns. Okay? Now, arrays by default pass arguments by reference. But in structures, it is passed by value. If you are not changing the value, it will be passed by reference if you are going to modify any entry. Okay? If the structure is very big, it can also be passed by reference. Now let's look at a program so we understand it better. Look at this program. I have a structure. Okay? My structure name is complex, and my structure has got two variables, real and imaginary. Two variables. Okay? Now, what I do over here, I declare my functions. I've got two functions, multiply complex and print complex. Multiply complex is going to return a complex data type, which is my structure data type. And print complex will not return any value. Okay? So in the main function, I create three variables of my complex. I create three variables of my complex structure, x, y, z. Okay? Which means x can access real and imaginary, y can access real and imaginary, z can access real and imaginary. This is just a repetition of what we studied in our structures lesson. Okay? Now, before that, let's again look at, I think here we have got the program divided into two slides, but I have taken it and put it in one slide so you can understand it better. Okay? Here's my structure. Structure name is complex, consists of two variables, real and imaginary. So that means whatever variable you create for complex can access this and this. This is my function prototyping or function declaration. Here's my main function. Besides the main function, I've got multiply complex function consisting of two variables, two arguments. I also have a print complex function which consists of only one variable. So what happens is, in the main function, I create three variables for complex, x, y, and z. That means x, y, and z can all access these two variables, and then I give a value to x and y for both real and imaginary, and then I calculate the value of z by saying go to multiply complex to do the calculation. Pass the value of x to this x. That means pass the value of both real and imaginary to this x, and pass the value of y dot real and imaginary to this y. Okay? Now, since you are passing the value, remember again, this is going to be by value, because it's a structure. By default, it is passed by value. Now here, I create another variable called temp, and then calculate the real value and the imaginary value, and then return the value of temp, which is returned and is stored inside z. Next, I call the print complex Yes, return value. Then I call the print complex function. So it goes to print complex, passes the value of z to this x. Z means it will pass both the real and imaginary value. It will be stored over here in x. So x also will have both real and imaginary. Why? Because it's of the complex data type. Okay, it can store both this and this separated by a dot operator. And then using a printf, I can show the value. Okay, very straightforward. This is a simple structure which uses call by value. Now, it can also be when you change the value. It's the same program like before, but what happens is over here in the main function, when you call multiply complex, it passes the value of x and y, okay, to multiply complex. The only difference is you see z, you're putting the reference symbol. That means send the address of the z variable to multiply complex, to the third argument. So it goes over here and passes it to the third argument. So this is going to be call by reference. Value, value, call by reference. Okay, so the value will be changed. Okay, so this is the only difference. And once the value of z is updated, you can call print complex. The value of z will be sent to x and the calculation will be done. Okay. So two scenarios of using your structures. It can be by default call by value, or you can also use a reference. As far as strings are concerned, when you pass a whole string, okay, it is treated as a vector, as a whole string. You can pass individual elements of a string as well. Now, this is another benefit of programming. Actually, most of the programs that we create are complex programs. Now, what is the meaning of a complex program? Let me explain that to you. A complex program means rather than having one file, you have multiple files working together. Okay? Any software that you install on your computer, it doesn't come with only main.c or main.exe. It has got a series of library files or perhaps cabinet files working together to create a user experience for you. Now, we are going to show you how you can create a complex structure. Now, look over here. In a complex program, you have got header files, you have got function declarations, you have got the main function, and you have got other functions. Now, the only difference is so far, you have put all this code in one program and saved it as main.c, execute and see the result. Now, what we can do is we can actually divide this program into segments and put these segments in different files. Yes, different files. It's possible. Okay. For example, where you declare your functions, put it in a file known as functions.h. Where you have your main function, put it in a file known as main.c, the usual file. And where you call the functions, put it in a file known as functions.c. Is this possible? Yes, it's very much possible. See, divide your program into 3 different sections and put it in 3 separate files. Is this possible? Yes. This is what an actual program looks like. Okay, you can complicate it like this. Now, you can do this even on any kind of software. You can do it in a Linux program. You can do it on your Dave C++, Boolean, anything. You see over here, my first program is code 9_9.c. This is given to you in Moodle as well as Blackboard. I have a structure, okay, and I have my main function. Now, the place where I declare my functions, you see over here, you call multiply underscore complex function. But have you declared multiply complex function? You haven't declared. You're calling print complex. You haven't declared. So the compiler is bound to give you an error, but the compiler will not give you an error. Why? Because you write over here hash include functions.h. So you're including this library. And what is inside this library? There is your declaration of the functions. See, two separate programs working together in tandem. Okay, now since you have included functions.h and now you call multiply complex, it goes to multiply complex function. When you call print complex, it goes to print complex function. But both these functions, the actual body of the functions, definition of the functions, is in another program known as functions.c. All these programs can work together to show you a result. Okay? But when you are executing the program, you have to execute it from here because the main method is here. Observe in functions.h, there is no main method. Observe in functions.c, there is no main method. So these cannot be the exe. The exe will be right here. Now, observe another thing, my dear students. Remember, I told you, can we have a program without the main function? Most of you said no, but you see here, there's no main function. Here, there's no main function. So we can have a C program without a main function, but you cannot execute it on its own. It has to execute with a program which has got a main function. Okay. Now, you can actually do this in your Dev C++. Okay. There's only one thing you have to do when you do it on your Dev C++. Look over here. I have a project. Inside my project, I have my functions.c, I have my functions.h header file, and I've got my main.c. Here is my main.c. Put all the three files inside one project and then compile your main.c, and voila, your program will work like a charm. No problem at all. Okay, you can try it out in your Dev C++. Okay, so multiple files to be executing one program. Remember, you need a header file, you need a source code file, and you need a main.c containing the main program. Okay, so today we discussed the structure of more complex programs, explore the use of more complex user-created functions, and explore the use of more than one file for a program. Now, some of these concepts you may want to implement in your assignment. Okay. Next, you'll do a practical, which will be taken over by Mr. Suresh. Please follow that. I hope you're doing the practical and emailing him the practical so he can give you some feedback. Okay. And next week will be our last lecture, which will be basic input and output. Okay. So that brings us to the end of this session. Do you have any questions that you would like to ask me? Anyone has any question?
So
Yes?
just now one of the in your previous code, where did you include the function.c file? Because I did not. I only saw the header.h file.
All of them will be in the same project file. You know, when you create a Dev C++ program,
yeah,
what is the first thing you do? You select it to be a .c. It's going to be a C program rather than a C++, correct?
Yeah.
Now, the first program by default will be main.c, correct?
Yes.
Okay. Now you right-click your project and select Add New File. Okay?
All right.
When you select Add New File, save it as functions.c or
Okay.
declaration whatever name .h. Just remember to include it in your main file. That's it. The only thing which has to be included is the header file.
So that means for the additional C files, we don't have to include it.
It will find it by itself. It's like magic.
All we have to do is just like put it in the same project together.
Yes. Put it in the same project. In Linux, you make sure again you put it all in the same folder. Okay.
All right.
You can try it out in your assignment as well. Just before, let me just count. So we have about 16 to 17 students. I believe some of you are traveling back home. So perhaps some students say that their flight will be at 3, so they won't be able to attend today's session. So they asked me to record it. So I told them, by default, I always record these sessions and upload it on Moodle so you can all follow it. Okay. Any other questions, my dear students? Are you concentrating on your assignment? 60%, my dear students. Okay. Open book assignment. Please don't mess it up. And remember what I told you. Work in isolation. Do not share code with your friends. Don't be kind to your friends and shoot yourself in the head. Okay, we have got so many bad experiences before. Students being accused of plagiarism and the results being held until mid semester. So please be careful. Try not to share your code with your friends. If your friends ask you for help, tell them, I'm sorry, I cannot do that. My marks can be at stake. Any other questions? Okay, if not, wishing you all the best. Do your assignments, do your lab exercises with Mr. Suresh, and I'll see you all next week. I'll send you the invitation for next week on perhaps Monday itself next week. Okay, it will be the same time, 2 p.m. Next week we'll have a session. The session next week is going to be our last topic, input output, but not the last lecture. The following week will be our last lecture where we'll do a revision session. I want to do a revision session with all of you so that we go through what we studied in the first week until the last week. Okay? And perhaps that will help us in our assignment as well. Okay, my dear students. Thank you very much for your attention. See you all next week. Please take care of yourselves. And I know that everything is a bit relaxed now, but still be careful when you go out. Please wear your masks and take care of your personal hygiene and be careful. Thank you very much.